Good morning students. Welcome to Anitha Study Planet. இன்னைக்குள்ள வீடியோல நம்ம என்ன படிக்க போறோம் அப்படினா System of Resistors. எலக்ட்ரிசிட்டி சாப்டர்ல கவர் ஆகக்கூடிய System of Resistors அப்படிங்கற டாபிக் தான் இன்னைக்கு படிக்க போறோம். இந்த டாபிக்ல நம்ம என்ன படிக்கிறோம் அப்படினா ஒரு சர்க்யூட்ல ஒரு எலக்ட்ரிக் சர்க்யூட்ல more than one resistors connected-ஆ இருந்துச்சு அப்படினா how will they perform? So total resistance என்னவா இருக்கும், total voltage, total current values எப்படி டிஃபர் ஆகும் அப்படிங்கறத தான் படிக்க போறோம். இப்போ இந்த சிஸ்டம் ஆஃப் ரெசிஸ்டர்ஸ்ல இந்த காம்பினேஷன்ஸ் அப்படின்னு எடுத்தோம் அப்படின்னா கிளாசிஃபிகேஷன்ஸ் அப்படின்னா மெயினாக டூ கிளாசிஃபிகேஷன்ஸ் ரெசிஸ்டர்ஸ் இன் சீரீஸ் அண்ட் ரெசிஸ்டர்ஸ் இன் parallel. இதுக்கப்புறமா போனோம் அப்படின்னா மிக்சட் காம்பினேஷன்ஸ். இந்த சீரீஸ் அண்ட் parallel காம்பினேஷன்ஸ் வந்து சேம் சர்க்யூட்ல மிக்சடாக வரக்கூடியதான் தேர்ட் காம்பினேஷன். ஸோ பேசிக்கான கிளாசிஃபிகேஷன்ஸ் resistors in series and resistors in parallel, that is series and parallel combination. So now let us study. So in the idhula vandu enna classifications, basic classifications, and vandu idhula circuit diagram eppadi draw pandrom, how will you identify the total voltage, total current and total resistance value அப்படிங்கறத இப்ப படிக்க போறோம். So first one, let us see the circuit diagram. First point is circuit diagram. So in series circuit, series combination of resistors, series அப்படினா one by one order linear connected ஆயிருக்கு. Therefore we can draw the circuit diagram like this. So let us study about three resistors, R1, R2, R3, three resistors connected in series with the voltage source or supply source, key voltage, supply voltage plus minus. Okay, and here in parallel combination the circuit will be like this. Supply voltage Vs, a resistor, parallel to this another resistors, and we can draw three resistors. So like this, you can draw n number of resistors in series and as well as in parallel. Switch this minus. Let us take this as R1, R2 and R3, three resistors. Okay. So second point, how the current varies in these combinations. Okay. Second point is about the current. Okay. In series combination, resistors are connected in series and always the ammeter, that is to measure the current, we used to connect to the ammeter in series with the currents. So ammeter with series la nama connect panni measure pandrom. Therefore the current will be same. Current is same in all elements or in all resistors in the series circuit. Current is same in all resistors. And here in parallel combination inga branching nadakudhu. Branching irundale current value enna agum, differ agum, current vandu branch agum. Therefore here the total current in the circuit will be IT and the individual current values will be I1, I2 and I3 to the individual resistors. The current will differ to the individual resistors. Second point, current differs in parallel combination. And third point is about the voltage. In series combination, current is same, but the voltage will be different. Normally நம்ம ஒரு சர்க்யூட் voltage measure பண்ணோம் அப்படினா voltmeter எப்படி கனெக்ட் பண்றோம், in parallel to the individual elements connect பண்றோம். So therefore across these individual resistances the voltage value will be differ, P1, P2 and P3. Therefore in series combination voltage differ across each resistors, across each resistors, whereas in parallel combination voltage is same because we can connect a voltmeter like this in parallel with all the system of resistors. Therefore voltage is same here, same in all the resistors connected in parallel. And next the fourth point, so we have to calculate the total resistance or equivalent resistors in the system of resistors. Third point is about the total resistors. Here the differing compound is voltage. Using Ohm's law we can write the relation as V is equal to I into R. Okay, here V can be written as supply voltage Vs and I is the total voltage in total current in the circuit and R is the total resistance in series combination. Okay, for individual resistances we can write V1 will be is equal to I into R1 and V2, the voltage across the second resistor will be equal to, using Ohm's law, I into R2 and the third V3 is equal to I into R3. Now let us add these three equations, V1 plus V2 plus V3. That is, the total supply voltage Vs will be equal to V1 plus V2 plus V3. So we can add these three. So Vs is again, it is equal to I into Rs is equal to IR1 plus IR2 plus IR3. And let us take the current as common. We can write the expression as R1 plus R2 plus R3. Okay. Now we can cancel out these two terms. Now Rs is equal to R1 plus R2 plus R3. Therefore, in a system of resistors connected in series, the total resistance will be equal to the individual sum of all the resistors. Individual values add பண்ண time நமக்கு கிடைக்கிறதா என்னது. Therefore Rs equal to R1 plus R2 plus R3. Therefore ஒரு series circuitல நம்ம individual resistance values எல்லாத்தையும் add பண்ணோம்னா we will get the total resistance value. Rs is the equivalent resistors in series combination. Okay. Whereas coming to the parallel circuit, here the different compound is current. Current differs. Therefore, using Ohm's law, we can write the same statement. Vs equal to I into R. Okay. Here R parallel. Rp denotes the equivalent resistance value. Okay. Now the different component is here current. Therefore, write the equation for current. I is equal to Vs divided by Rp. Okay, likewise write the equation. Now write individual equations for all the resistors. So what will be I1? I1 is equal to Vs divided by R1, and I2 will be equal to Vs divided by R2, and I3 will be equal to Vs divided by R3. Now add these three equations to calculate the total current. So I will be is equal to, total current will be equal to sum of individual current value, I1 plus I2 plus I3, which is equal to, so I value we can write it as Vs divided by Rp is equal to Vs divided by R1 plus Vs divided by R2 plus Vs divided by R3. Therefore, taking Vs as common outside, we can write as 1 by R1 plus 1 by R2 plus 1 by R3. Now we can cancel out these terms. Therefore, for a parallel system of resistors, 1 by Rp, total resistance 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay. So likewise, we can calculate the total resistance value for a series circuit and a parallel circuit. Okay. Therefore, resistances series la connect பண்ணிருந்தோம் அப்படினா equivalent resistance or sum of resistance will be equal to R1 plus R2 plus R3. சில resistors add பண்ணா போதும். இங்க the reciprocal of the equivalent resistance 1 by Rp is equal to ஒவ்வொரு individual resistance reciprocal பண்ணி நம்ம add பண்ணக்கூடிய அந்த total sum தான் இதுக்கு equivalent ஆ இருக்கும். Okay. Therefore, the further இந்த equation நம்ம வந்து simplify பண்ணலாம் for our convenience. If two resistors are connected in series parallel. Okay, if two resistors are connected in parallel, say as R1 and R2. So 1 by Rp is equal to 1 by R1 plus 1 by R2. So taking LCM, we will get it as R1, R2 and R1 plus R2. We can simply we can write it as Rp is equal to, reciprocal of this term is equal to, here reciprocal is R1, R2 divided by R1 plus R2. That is, if two resistors are connected in series, in short, you can calculate like this. Otherwise, like this, for three resistors. For three resistors, we can write Rp is equal to R1, R2, R3 divided by R1, R2 plus R2, R3 plus R3, R1. Okay. Next, the fifth point. So fourth point is about the equivalent resistance or total resistance. And fifth point, if the same valued resistors, n resistors are connected in series. For example, 1 ohm resistors of n resistors. N resistors are connected in series. Series connect பண்ணிருந்தோம்னா what will be the total resistance? So Rs equal to R plus R plus R plus up to n times you can write. Therefore, for n resistors connected in series of same value, then Rs equal to n into R. And here, if n number of resistors of same value connected in parallel, then Rp for n resistors, 1 by Rp is equal to n divided by R. Okay, and likewise, another relation we can study, sixth point. If some resistors are connected in series, 1 ohm, 2 ohm, 3 ohm. For example, 3 resistors, 1 ohm, 2 ohm and 3 ohm. 3 resistors are connected in series. So what will be the total resistance? Total resistance Rs equal to 1 plus 2 plus 3, that is 6 ohm. Okay. Therefore, if resistors are connected in series, the total resistance or equivalent resistance will be high in series. So individual resistance value விடவும் the total resistance value higher இருக்கும். So total resistance will be increase in series combination. Whereas in parallel combination, if the same resistance 1, 2, 3 are connected in parallel, 1 ohm, 2 ohm and 3 ohms are connected in parallel, using this formula you can write Rp is equal to 1 into 2 into 3. So 1 into 2 into 3 divided by R1 R2, 2 plus R2 R3, 3 2s are 6 plus R3 R1 3. So 6 divided by 11. Okay. Therefore, the individual value resistance, the total resistance will be decreases comparing to the individual value. So in short, in series combination, the total resistance will be high. Okay, over individual value விட total resistance value அதிகமா இருக்கும். இதுவே parallel combination ல total resistance value ஒவ்வொரு individual value of resistance விடவும் கம்மியா இருக்கும். Okay, so that's all about the resistors in series and parallel combination. Thank you.